Okay, so let's look at this question. So this question is based on the k-mean algorithm. Consider the following dataset. We have given the coordinates of the point, and the k-mean algorithm is initialized, and we have initialized our centroid at point A and B. Upon convergence, the two center will be at, so option A, option B, option C, option D. So we can, how we can solve this? So this is not a, so we have only few data given, right? And even you look at the data that is on x-axis or y-axis. So A is here, right, at 0, 2, and sorry, and B is at 0, 1, and C is at 1, 0, maybe here, right? So the first point, and our centroid is, the first centroid is at itself at mu 1 is at A and mu 2 is at B. So what we do in k-mean, so this is the first centroid and this is the second. So we are going to pick our centroid mu 1 and mu 2, and what I will do, I will calculate the distance of this mu 1 to the data point. So let's look at this first A, right? So mu is itself on A, right, and mu 2 is far from this A, right? So this A will be in the cluster of this mu 1, right? So that is the one point. And second, let's look at now the second point B, second data point B. So B is near to this centroid mu 2, so B will be in the cluster of mu 2. And let's look at this C. So C is near to mu 2, so C will be in the cluster of mu 2. So at the first iteration, in cluster of mu 1 we will have point A, and in cluster of mu 2 we will have point B, C. Now what's the next step? Next step is to update your centroid. So mu 1 will be again at the same position, that is mu nu is equal to at A, so A is at 0, 2, and this mu 2 will get updated to 0 plus 1 divided by 2, 0 plus 1 divided by 2. So now mu 2 will be somewhere here at this midpoint, at half and half, right? Now mu 2 is here and mu 1 is here. Now it has got converged, right? How we can confirm that? Again, pick the first point and calculate the distance from mu 1 and mu 2. So that A will be in the cluster of mu 1. Now pick the second point and calculate the distance from mu 1 and mu 2. B is near to mu 2, that means B is going to be in cluster of mu 2. And now pick the third point, calculate the distance from mu 1 and mu 2. So C is also going to be in cluster of mu 2, right? Again, after calculating this, after assignment, again we saw that we are getting the data point in our cluster is same, so update is going to be the same. So there would be no change on the cluster centroid. That means algorithm has been converged. You can stop. So once you will stop, then you will find that A and the midpoint of BC. Upon the convergence, the two centroid will be at A and the midpoint of BC. So that is the answer for this question. Okay, so let's look at this question. So which of these classifier could have generated the decision boundary? So we have given these options, right? So which classifier would give you this kind of decision boundary, right? You see that this is a decision boundary, also this is in the decision boundary, and all this small you see the lands, all these are the decision boundary, and it is classifying each and every data, right? So we have two types of data here, one in the golden color and one with the blue color, right? So do you think that linear SVM, support vector machine, would be able to uh, give you this kind of decision boundary? And you see the decision boundary is you can say very complex, right? And and even it is not even it's a complex, but you see that all these decision boundaries are in form of, you can say, Iceland, right? In form of some piece of the lands, right? So this is the point is that linear SVM cannot generate this kind of uh, highly complex highly complex decision boundary, and even the logistic regression cannot generate this kind of non-linear decision boundary, right? And now we are left with the 1 NN and none of these. So what is this 1 NN? 1 NN is the KNN, where K, what we are taking is 1, right? So how you will taste this? So since we have this given this 1 NN, right? So K is 1. So in nearest neighbor, what we do, we do not have any kind of training there, right? We do not first train our, and we would have the model, and then we will give the input, and then we will get the output. No. So how this nearest neighbor works, what you do that you will have the data, right? And the data will have the, let's suppose that your data have the two class, the gold and this blue. So in 1NN, what it is going to do, let's suppose that you put your test data somewhere here, maybe let's take maybe here, right? So since we are using 1NN, that means one nearest neighbor. So what it is going to do, it is going to first of all calculate the all the distances from this test point to all the data, to all your trainee data, right? And now it is going to pick this test data, is going to pick one nearest neighbor out of, so how it is going to take that one nearest neighbor based on the distance that it has already calculated. So it will see that yes, this is the nearest neighbor that will come into his proximity, right? So this test data will be assigned as the gold color, right? So you see that we have already here the decision boundaries, right? Now let's look at uh, these two points. One is here, that is blue one, and one is here, that is with the gold, right? And you see that we have the decision boundary, you can assume like this one as a black one, and you can see that the distance from this and this is approx, or you can say equal, right? That means any test point that is outside this boundary, that will be assigned as the gold, and any point inside this boundary, that will be assigned as a blue color, because once you are inside this boundary, then it is going to be near to this blue one, and once you are outside this boundary, then it is going to be near to this one. Let me pick any other, and you can taste and you can justify yourself, convince yourself with any point. Let me So you see that here also we have two distinct classes, that is one with the gold and one with the blue, and here we have also boundary, like, right? So you see that how it is classifying it, right? So if data point is here, that means it is too near to this orange one, that this the gold one, and if test data point is here, that is going to be uh, uh, and okay, I think and also few questions. You see that with one nearest neighbor, that if we are considering one nearest neighbor, in this case you are observing that each and every data is getting classified, right? And it will be, right, if you are for the test data, if you are picking one nearest neighbor, then, right? So okay, so my question is here that that if we increase the value of this k, right? Let's suppose we take the k is equal to 5, 6, 7, 8, 9, which have the highest bias, right? 1 nn or 10 nn, right? Which have the highest bias, 1 nn and 10 nn, right? And also let me know which will have the, if we so let me make the question like this: if we increase the value of k, tell me about the bias and the variance. If we increase the value of k, that is the number of nearest neighbor, what would be the bias in, if we are increasing the value of k?